So we will now start with Chapter 2, which is going to deal with our first main topic in calculus, which you remember is limits. This is just going to introduce you to the tangent and velocity problems, as Section 2.1 is called. So, as you may remember in geometry, a tangent line is a line that touches a curve once. In geometry, you saw it with circles, and it would touch the outside of the circle once, where a secant line is going to go through the curve twice, or touches any curve twice. So, for example, if I have a parabola and I want to draw a secant line, there'd be a secant line. It goes through the curve at 2 points. Versus if I want a tangent line and I have a parabola, it's just going to touch the parabola on the outside at 1 point. It's kind of hard to see or to draw completely to scale. Okay, so our first example that's going to introduce us to limits is to find the equation of the tangent line to the parabola, y equals x squared, at the point 1, 1. So I have it drawn already. I have the parabola drawn, and I actually have the tangent line. So the line on the outside that I'm going to just go over in blue, that's the equation that we're trying to find, the equation of that line. Now the problem is we only have 1 point. So to find the slope, as you know from Algebra 1 and Algebra 2, you need 2 points. So to do this, we're actually going to use secant lines. The idea being that if I take another point, let's say at 2, 4, so if I take the point 2, 4, which would be up here, and I connect these 2 points, now I have a secant line, and I can find the slope of that line. We know how to find the slope of a line between 2 points. So if I have the point 1, 1, I have the point 2, 4. If I find the slope between those 2 points, I'm not going to show the work, I get 3. So the slope between those 2 points is 3. If I do 4 minus 1 over 2 minus 1. Now the idea is if I move the point that I start with, which was at 2, 4, closer and closer to 1, 1, and I continue to find the slope of those secant lines, I will get closer and closer to the actual tangent line. So what am I talking about? If I take 1, 1 still, I have my point 1, 1, and now I find the slope of the secant line that goes through 1, 1 and 1.5, 2.25. So 1.5 I'm just choosing because now it's going to be closer to 1, 1. So if I take orange and I say, okay, so 1.5 would be the orange point. And now I find the slope of the line that goes through the orange point in 1, 1. I get 2.5. Again, you can trust me by just subtracting the y's, subtracting the x's. If I continue to do this, so now I start with 1, 1. I bring my point even closer, let's say at 1.25, and the y value would be 1.5625. Okay, so now all I've done, if I take a different color, is now my point is the pink point. And if I connect the pink point and my point 1, 1 and find the slope of that new line, it is 2.25. Okay, so I'm just going to keep doing this. Take 1, 1, and if I get even closer and say I find the slope between 1, 1 and 1.01 and 1.0201. So all of the y values I'm finding by just squaring the x values. These are all points that are on the parabola. If I find the slope between those 2 points, it actually is 2.01. I'm going to do one more. If I go 1, 1 and 1.001, and the y value to that is 1.002001. So now if I find the slope between 1, 1 and 1.001, it comes out to be 2.001. All right, so what have I done now? So all I'm doing is I have my point 1,1, and I started with a point 2,4, and I connected those two and found the slope of that line. Then I said, okay, well, let's get closer to 1,1. So then I came all the way in here, and I connected this and this point to my original 1,1. I found the slope of that. Then I came even closer and closer and closer. So as I do that, you can see that the slopes started at 3. I got 2.5, 2.25, 2.01, and 2.001. So you could guess that what would the slope of the tangent line be? Oops, sorry. So the slope of the actual tangent line is 2. Hopefully you guessed right. I could keep doing this if I wanted. I could do 1.0001, and it's getting closer and closer to 2. So now I know that my equation of my line is y minus the y value, which is 1, equals the slope 2 times x minus the x value, which is 1. So again, what did we just find? Here's the parabola, here's the point 1,1, there's my tangent line, which just touches it at 1 point. So the equation of this line is what I just did in point slope form. So x and y value are 1, and the slope is 2. If you want to go in your textbook on page 82, they have 2 tables, what I just did, finding the slope of the secant lines as I get closer and closer to 1,1. And in class on Tuesday, we'll look at this demonstration, which actually shows bringing the point closer and closer. If I just try to do it on here, so here's 1,1, guys, and I started with a point here, so literally there's my first tangent line, and then all I'm doing is I'm bringing the point closer and closer and drawing new tangent lines. I know this is bad with one color, so I'm bringing the starting point here and getting closer and closer and closer and drawing a line to find the slope between them. Okay, so that I will talk about in a second is a limit. So the next problem we're going to look at is the velocity of a car. Or just talk about, before we get to the velocity problem, just the velocity of a car. So obviously velocity is not constant. As you're driving, your velocity is never constant at a moment in time. I can look at average velocity as my average speed at which I traveled between 2 time periods. So let's say between 1 second and 3 seconds, what was my average velocity? And this is just like the slope. And I would just find the slope of those 2 points. Okay, so how do we find velocity? We find the change in distance. Change in distance over change in time. How would I do that? I would have 2 different points. I'd say after 1 second, I've gone, let's say, after 1 second, I've gone 5 meters, and after 3 seconds, I've gone 20 meters. How would I find my average velocity? I would just find the slope between those 2 points, 20 minus 5 over 3 minus 1. Now, instantaneous velocity, I actually want how fast am I going at 1 point in time. So this is my velocity at 1 moment. So I could say to you, what was my velocity after 2 seconds? So after driving exactly 2 seconds, how fast was I going? So hopefully you can see that instantaneous velocity is like slope of a tangent line, where average velocity is like slope of a secant line, because you have 2 points for average velocity, where you only have 1 point for instantaneous velocity. So common problem is I want to find my instantaneous velocity. Okay, so a ball is dropped from a deck of a tower. 450 meters above the ground. Find the velocity after 5 seconds. So at 5 seconds exactly would be instantaneous. It doesn't say that, but it would be instantaneous velocity because it's after 5 seconds. Use the model for free-falling objects. So I have my equation given, 4.9t squared, and I want to estimate the slope. So I want to do this by estimating the slope using the slope of the secant lines. So in order to find my instantaneous velocity at 5 seconds, that's really saying find, so 4.9t squared would just be a more narrow parabola. After 5 seconds, let's say the point's here, I really want to find the slope of the tangent line again. So we're going to approach this the same way. I'm going to find the slope of secant lines as I move closer and closer and closer to this point. So what we would do is we'd find the slope between the points 5, when x is 5, and 5.1. So I'd find the slope between 5.1. Those 2 points. How do I get the y value? Plug 5 into the equation to get the y value, and I would plug 5.1 into the equation to get this y value. And I'd keep doing this, and to bring it closer, I would say 5.01, and I'd find the slope between those two. And then I would go from 5 to 5.001. All you're doing again is I'm finding the slope of the secant line as I get closer and closer and closer to when x is 5. Okay, and just to kind of cut down some of the work on the side, I don't think I need to do. The slopes are, the first one comes out to be 49.49. The second one is 49.49. And the third one is 49.0049. So, if you've all guessed that the answer is 49, you are correct. Because as I'm getting closer and closer and closer to 5, my slope of the secant line is getting closer to 49. Okay, so find the velocity after 5 seconds. So the velocity after 5 seconds would be 49 meters per second. Okay, because that's what this is getting closer and closer to as I find the slope between those points. Okay, so I've already said this, but I'm going to write it. Average velocity is slope of a secant line, because y, you have 2 points where instantaneous velocity is finding the slope of a tangent line, because I only have tangent line because I only have 1 point. Okay. And the big idea here is to find the slope of a tangent line. Okay, to find the slope of a tangent line, what are you going to do? The slope of the tangent line equals the limit of the slopes of the secant lines. Okay, so as you find the slope of the secant lines, the slope of the tangent line is going to be what that number is getting really and really close to, which is a limit. Here's the introduction of a limit. We'll talk about notation. We'll talk about much more in the next couple of sections. Right now, this is just an introduction, and you will have to find, using a table or doing slope over and over again, you will have to find the slope of the tangent line based on finding secant lines as you get closer and closer.